Hey guys, this is Mike, and this is part 3 of the Connect Me development. So, in the last video, we set up the grid and cells and swapping of cells. So now in this video, we're going to check to see if the puzzle grid is solved, like this one is. So, the algorithm that we have to use to do this, let me just, or not. So basically, the algorithm that we're going to be using to solve this is pretty much breadth first search or depth first search. Either one of them is going to work. So what's going to happen is basically I'm going to go through the entire array using a double for loop, and if I reach one cell of a certain color, I need to mark that down. So let's say I start over here on this cell. Hold up. So I start over here on this cell, I mark it as visited, and I also mark it as blue. So over here I'm going to keep like a list of blue. This is called finding the connected components, and I'm going to mark blue as, let's see, I found one at 0, 0. And then I'm going to use depth first search or breadth first search to find all other adjacent blues to this one. So it's also going to add 0, 1, 1, 1, and 2, 1. And then that's it. That finishes the first cell. So the for loop goes to the next one. This one is blue. Oh, right. And while I'm creating the connected components list, I also have to mark each one that I go to as already visited. So I continue with my for loop. This is the next one, since I just finished this one, but then I see that I've already done blue, and I've already visited it. Oh, this should be a 1. I've already visited it over here. It's already checked, and I can skip that one. So I go over to the red, I mark that there, and then I use search to find all adjacent reds, and I'm going to set that up also. Red is going to be 0, 2, 1, 2, and 2, 2. And then next up is going to be green, and again, same exact stuff here. I'm just going to mark it, and I'm going to have my final green over here. What is this? This is 1, 0, and 2, 0. And if I continue, I see that I've already visited these, so it goes all the way to the end, and I know it's finished. So if I had a puzzle that was not finished, let's say I had something like this. I'll just do that or something. The red is not adjacent to the other red, so this is not finished. So what would happen is I would do the same exact algorithm. I got the reds over here, and I'll mark that in here. Then that's finished. I'll go to the blues. I'll mark all of those adjacent. But then when I get to red over here, I notice that I've already visited red, and this has not, or I've already checked the red color over here and over here, but it's not visited. So I know that this is not solved because I've already checked all the reds, and there's another red here that has not been visited. So that just short circuits, and I stop checking on this one, and I know it's not solved. So that's pretty much the algorithm. Let's see if we can try to make it. Totally forgot how the search works, so I'm on Wikipedia here. And they have pseudocode. Breadth first search. So I'm going to try that one. So I'll just put it over here. Public void check finished. Okay, it says procedure BFS non-recursive implementation. That's fine. So it uses a queue. That's, I know breadth first or depth first search uses a stack. Right? I hope I'm not wrong there. So anyway, what do I need? I need a list of visited. So the labels. I need a Boolean array. I'm going to call this visited, and it's going to be the same size as the grid. I also need to keep track of which colors I've already checked. Colors, and this is going to be just the number of different color cell types that I have, and I already have an array of those cell type values in cell. That length, and so everything's false right now. So I make my Boolean visited and checked. I need a queue. Queue of what? Let's see. I guess they're just gonna be cells, right? Let's call it queue. Uh-oh. Alright, this is a, what do you call it? Interface or something? Or abstract? One of those. So queue. Let Q be a queue, q.nqv. So I need to queue the first one. That's cell 00. So q or q.add. Is there an add? Yeah. Q. The first one is grid row column or grid 00. And then not discovered, or label that as discovered. No. I thought the algorithm was I go through the entire array. Or, do I need? Yeah. Yeah. For and column is 0, column is less than num, column is column plus plus. So I need to do BFS on this stuff. BFS on grid and row and column. I also need to give it the visited array so I can change stuff in there. Private void BFS. So the grid, the visited array, and int row and column. So I need to do BFS here. So this is where I do the queue stuff, not up here. So I need to enqueue. This is going to be grid row column or queue.add. Label it as discovered. Visited row column is true. While queue, not queue empty. DQ v dot, or it says v there, but that's a cell. So cell current cell is equal to q dot. It's weird. They call it poll instead of DQ and NQ. So poll is the same thing as DQ. process v. What does that mean? Don't really need to process it. Oh, whatever, I'll skip that one for all edges. So here I need to find all the connected edges. So I need to check up, down, left, and right. Or if they're on the edge, skip those. So if row is less than or is greater than 0, then I should, okay. So check left is going to be if column is greater than 0, or is, yeah, it's greater than 0. I don't want to check left if I'm on the left edge. So if not labeled as discovered, if visited row column -1, if not visited row column -1, then NQ and label it as discovered. Oh, Jesus. For all edges, then NQV, so q.add visited row column -1, label it as discovered. No, not visited, it's grid. Then label it as discovered. Visited row column -1 equals true. So I need to do this with up, down, left, and right. Column is less than num columns -1, right? I don't want to check the rightmost edge. If not visited row column +1, q.add grid row column +1, visited row column +1 equals true. Should have just copied and pasted that. Again, this is probably something I could compress since they're all pretty much the same, but I'll do that later. Row is less than, or row is greater than 0. If not visited row plus row -1 column, q.add grid row -1, space there, column, visited row -1 column is equal to true. And the last one, if row is less than num rows -1, row +1 +1 +1. Okay. Let's see. That should do it. But remember, the algorithm is that if I ever here, that's red, green, red, but I've already visited red, and this is not visited yet, or I've already checked red. So I probably need to pass the check colors as well. Checked colors. So I need to, so I'm visiting this one, so checked colors. I don't need to do it here because I'm checking, that's the first thing I'm checking up here. So if checked colors, okay, so int type is equal to grid row column dot get type. Oh, I need that up here. I need a getter for the type. Cell type dot get type. return cell type dot ordinal. That's just the order that it is in the enum. So red is 0, green is 1, blue is 2. Obviously, if I change the order, then it's going to change the ordinal. So that's the type. So if checked colors type is, if it's false, and or no, if it's true, if I've already checked it but it hasn't been visited, then return. And I should probably return this boolean. False. Okay. But if it goes properly, then it should just return true. It just finished the whole thing, right? What am I doing here with this? What's the algorithm? V, process V, just V to W. Not really doing anything with it, because I'm not processing it, but I still need to remove it from the queue. So probably don't need this. That looks fine. Okay, so when do I need to check finish after every single move? So where's the move? Right here. So check finish. If check finished, I should probably call it is finished instead. I'll just print out finished. Okay, let's see if it works. Please work here. It's not finished, but it's still printed out. That's awesome. So what in the world happened? Check colors. Oh. Checked colors type. I need to set it that I've already checked this color. It's true. Alright. It's still finished. What in the balls? This is a different line. Checking type. Check colors. Obviously this isn't happening. System row. This is what I do all the time. Print statements. I could probably use the debugger, but I'm more comfortable with this. Row, column, ordinal type. I'm checking two things. Check type, visited row column. I'm setting to visited down here, right? Yeah, add it and set visited to true. I should probably do print visited over here or over here. Yeah. I know I have for loops somewhere. Row row column. Okay. Let's see. Boosh. So what is going on? Checking type red. True. 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 That obviously is not right. Checking type at row column. At 0, 0, that's red. So it checks this. True, true. Why are these true? Why are they true? So it sets that first 0, 0 to true. Oh, it's because I'm... Oh, because I'm not actually checking to see if that color is the same. Int type is equal to current cell dot get type dot ordinal. Or I don't need the ordinal. I just do cell type current cell dot get type. And I need to check and grid row column -1 dot get type is equal to type. That makes much more sense. Column +1 dot get type equal to type. Just copy and paste this. And grid row -1 column nothing. And here grid row +1 column nothing. That okay, let's see what that does. Checking, okay. Checking type 0 at 0, 0. Okay. It didn't visit any of the other ones because there's nothing to visit. Green as well, nothing to visit. Check type 0 at 0, 2. It failed, right? System.out.println failed at row plus column. Failed at 0, 2. That's right. If I go here, if I switch these two, it should be solved. Right? Failed at 2, 0. 2, 0 is this one. It didn't check to the left. So the last, it checked all the reds. True, true, true. All the greens, true, true. And it's checking type FF here. So all the blues, it checked the blues here. This is true, but it didn't go left. Why didn't it go to the left? That's column numcals lesson or -1. It should be this one. Column is greater than 0. If not visited, it's not visited. Is the type not the same? I don't. System.out.println. Let's see. Type plus not visited row column -1. plus grid row column -1 dot get type. I don't know, let's just double check that one. So if I switch this and then this, checking type 1 at 1 at 1 checking type blue, false, green. It checks downward. Why did it skip? I queued it. Queue.add. It's not empty yet. It shouldn't be empty yet. Failed it, whatever. So this is another one. True. Checking 0, 0, 0. 0 at 0, 1. First off, this is wrong. Oh boy. Let's see. Okay, let me try that one more time. If I do this, or no, if I do this, failed at 1, 0. That's fine. Checking this. Let's use the 2 reds. Checking type 0. That skips that. Checking green. That's fine. 1, 0. Already checked that. Failed at 2, 0. That makes sense. Failed still at 2, 0. It went down here, but it didn't check left or right. So it started with blue over here, went down, but it didn't go left or right. Why did it not go left or right? Hold up. Oh, it says finished here. What? That's finished. It finished. But over here it fails. Because it doesn't check this one and this one. But over here it checks all of them. So my breadth first search isn't searching everything. Weird. If not visited, this is going. This is going to the left. I'm checking if I'm over here. If I'm down here. Okay. Okay, hold up. This one I don't line or. Because I think I know what the problem might be. Yeah. So when I get the current cell, I can't use row and column anymore. Cell.type. So I need to know what the row and column of this is. So maybe instead of a array of those, index. Ooh, yeah, this is something that I thought should not be this difficult. So instead of a queue of cells, I'm going to use a queue of index. And index.add new index row column. Visitor row column is true. Current cell. Why not? I'll just call it index here. Q.poll. Type. Oh, I need the type as well. The type is just grid current cell dot row current cell dot column that get type q dot add row column -1 row column +1 and row -1 and row +1. Oh, hopefully that works now. Failed? Failed. It still didn't go left. Why doesn't it go left? Visiting so checking 2 at 1 2, visiting 1 2, visiting 2 2, and then it stops. Why does it stop there? There's more to check. F over there, to the left. Is it, so one of these is failing, one of these two conditions is not making it. Oh, damn it. Okay, I get it, I get it. So everything is using row and column here, and those need to change, so I'm just gonna do row columns current cell dot column. Failed. Finished. Oh, there we go. Oh my god, was that the problem? Fail, 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 finish. Fail, finish, fail, 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 finish. Oh my god. Finished. Oh, finally got it working. Let's get rid of all these print statements because, hey. Let's see, get rid of these. Prints over here. Alright. So it does finish. I'll leave this one here just so I know it's finished. Cool. Prints out twice though. Why does it print out twice? Oh, because I already printed out over here. Oops, don't need this one then. So yeah, cool. It works. Finished. Nice. Let's try it for a larger grid. Let's do a 2 1 0. Oh, has an extra spacer, right? Because I assumed it's gonna be a square grid. 1, 1, 0, 2. Let's see. 1, 2, 3. Oops. So that was way too many moves. I should probably do the move counter here now. Not sure if I should put it in play state or grid though. I don't think it could be part of grid, but I'm gonna keep it out here. No moves. No moves. Let's see if grid.move, grid.move. No, but then I have to return if the move actually happened. Yeah, I'll just put it in grid. Private int num moves. Okay, set it to 0. Public void reset num moves has to go back to 0. Oops. Num moves 0. Actually, I don't think I even need that. Because I'm creating a new grid every time a new puzzle comes up. Never mind about that. So over here, check num moves plus plus. I'm gonna refactor all of this later. This is just 4 copies of this. Number of moves. Alright, so when I finish system, I should also print out number of moves. One, 2, 3, 4, 5, 6, 7, 8, 9. It didn't print out the number of moves. What? It just print out finish? What? That doesn't make any sense. What? 1, 2, 3, 4, 5, 6, 7, 8, 9. Why doesn't it print out number of moves? Are you kidding me? Oh. Oh. What? Oh. Oh. Oh god. I swear I'm gonna change this. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 moves. That's a lot for this. This is like a Rubik's Cube puzzle solving thing. The next, I'm not gonna do it next because this is a little more involved. But the next thing, one of the things I'm gonna be doing later is to find out the minimum number of moves possible to solve a puzzle. That's gonna be, oh. So yeah, that's gonna be probably the biggest part of this game, and it's gonna take me a pretty long time to figure it out, is to, given this grid, what is the least number of moves possible to solve it? How in the hell? I'm probably gonna have to use shortest paths for this, and I'm gonna have to check pretty much every single combination. If I want to be absolutely sure, I should use brute force, just check every possible combination. That could take a while. Or if I want to do something less brute force-ish, I could use an AI with a heuristic, but I wouldn't know what the heuristic is. So I'm probably just gonna brute force it. So right now, as for me, I see 9 moves. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's even worse than what I did before. Anyway, so I'm not going to be doing that next. That's going to be for later down the road because it's not even required at this stage. So I'm not sure what I'm going to do in the next video. 11 moves. What else? What are the other features that I'm going to need for this game are rating system or star system. After you finish a puzzle, I'm going to have it be like a 4-star system over here. Oops. I'm going to use a 4-star system, and you get 1 star if you finish it, and you get 2 stars if you finish it with the min number of moves times 2. So let's say the minimum number of moves to solve this puzzle is 9. You'll get 2 stars if you finish it within 18 moves. You'll get 3 stars if you finish it with min times 1.5. So here you'll get 3 stars if you finish this in 13 moves. Assuming the minimum number of moves is 9, and you'll get all 4 stars if you actually finish it in the minimum number of moves. Which, for a puzzle like this, is probably insanely difficult, if not impossible. 4x4 is just, oh. For figuring out 4-star solution, that is insane. Probably people that are going to be playing this are probably going to have like OCD issues, not getting 4 stars on everything. Because, no, seriously, this is a pretty hard problem, trying to find the minimum number of moves yourself without using any brute force. For a 4x4, that's insane. But I'm still going to keep it like this, so you're not going to get 4 stars all the time unless you make a program. Or unless you're like a genius and you can just see all the patterns. There's so many different ways to finish this thing, but to do it in the least number of moves, that's tricky. Like that even works, or that even works. I think one of the ways to get this finished is if you're not clumping everything. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nope. 10, 11, 12, or 11. And you probably increase the number of moves by 1 there. But yeah. That's gonna be it for this video. And let me just put it on the repository. Checking if the grid is solved. Cool. Yeah, but that's awesome. So if anyone has learned all those discrete structures, algorithms, shortest paths, Dijkstra, A-star, searching algorithms, DFS, BFS, here's a practical application of it. If you thought you're never gonna see it again, here it is. So it's good to know at least the more well-known algorithms like BFS or DFS, and at least some shortest paths, or if you don't know like the code like I do, at least know how it works so you can look it up and know immediately like, oh, that's how it works, right? It's BFS and DFS exactly the same except they use a queue or a stack. You can also search for shortest paths, stuff like that, which I'm going to be using later to find the minimum number of moves, because I need to backtrack and see. Do I need to backtrack? if I can backtrack if I want to know the exact move order or which moves to make to get to the minimum number of moves. I am assuming it's going to actually take a while to figure out the minimum number of moves, even if I use a computer here, because the number of possible permutations of this increases pretty exponentially. If you increase the size of it even just by 1, a 5x5 grid would probably take a very long time to figure out. So yeah, I'm just rambling at this point. So yeah, that's going to be the end of this video. Yeah, thanks for watching.